Good morning everyone, my name is Mohit Gupta and I am here to explain my project on travel rating reviews. And here I had prepared my project and the ML model for this project. Now here we can see I had imported all the essential libraries that are required for my project. And now here I am loading our dataset that is provided. And now let's do the pre-processing required for our data set. And in pre-processing, we are dealing with missing values and seeing the unique values present in our dataset and the shape of our dataset, that how many rows and columns we have in our dataset. And the number of rows in our dataset is 5456 and the columns is 26. And now let's overview our dataset data frame using the df.head. And we can see here we have one column named user and having values user 1, user 2, user 3, user 4. This column is not necessary or useful for our model training, and we can see all other values are float, and one column named unnamed 25, this is having missing values, so we have to remove both the columns. Now let's rename our columns. As we can see here, we have column named category 1, category 2, category 3. To simplify and make our dataset more understandable, we will rename our columns using this column list. And now let's see the categorical and the numerical value present in our dataset and using the df.info. And we can see here that we have one column named user ID and one column named local services are having the categorical values, and all other values are float values, that is numerical values. We don't have to bother about the float values, we have to bother more about the categorical values, because data set having the categorical values is not nice for ML models, because ML models are applied mostly on the numerical values. Let's see unique values present in our dataset. And we can see here the user ID column has many unique values, and the column named unnamed 25 having only 2 unique values. And we have also seen above quotes that we have to remove these 2 columns. These are not nice columns for our model training, so we are dropping here those 2 columns and putting the data frame using those values using in place is equals to true. Now let's see the missing values present in our dataset. So we have used this command df.isNull.sum, and we can see that we don't have many null values or missing values in our dataset. We have one missing value in the burger pizza shop and one missing value in gardens column, so we have to impute those values. Let's see the exact rows in which these missing values present, and we can see here that one missing value is here and one missing value is here. We can also see one object value, that is categorical value, present in local services, which we have seen here, the object values. So we have to remove that also and make that also in the numerical value. Now we have to, in order to change the categorical value in the numerical value, we have to first change it into the null value, and here we are doing this, that converting the categorical value into null value. And then we have applied the simple imputer and used the strategy mean to impute the values of null values, because removing the column or row is not a nice approach to deal with null values, because it will affect our dataset and the prediction of our values that we will be doing. Now after doing all the data pre-processing, our data frame which came after being processed is this data frame. And we can see that the categorical value which we have in the local services is also converted into the numerical value using the imputer, and all columns are now having the data type float, which is numerical value. Now we have completed the data pre-processing. Now we are doing exploratory data analysis, that is EDA. Here I have prepared a heat map of the correlation between each column. We can see here columns are not highly correlated with each other. So now I am preparing a pair plot, and using pair plot also we can see the relation between the columns with each other. And here we can see that one column theaters having the direct relationship with column named parks, and similarly we can see the relation between the other columns with each other. Now let's do statistical data analysis, because all our columns are having float values, that is numerical values. We can perform statistical analysis, and here we can see the number of values in each column present. And now we can also see other properties of our dataset, like mean of the dataset columns and the standard deviation, minimum value, first quantile value, median value, third quantile value, and the maximum value. And the maximum value for our dataset is 5 and the minimum value for our dataset is 0. We don't have any negative value in our dataset. From this we can infer this. And now I am plotting the graphs of all the columns that we have in our dataset, and we have to look at whether our dataset columns are normally distributed or not. And we can say that the churches column is nearly normally distributed and other columns are not normally distributed. They are having not a graph which is resembling like normally distributed graph. Now let's get some more info from our data set and get more details from our data set. And here we can see the number of reviews under each category, and the gardens are having the highest number of reviews along with monuments, viewpoints, and etc. And the minimum number of reviews are given to churches. Now let's see the number of categories that are having the number of reviews, and the category number 24 has the highest number of reviews. Now let's see average rating per category, and we can see from this graph that the malls are having the highest average rating per category, and the gyms are having the lowest average rating. Now I am plotting a box plot, and using the box plot we can see that we have many outliers, but I'm not removing the outliers because that contains a large portion and it will affect our data set and could alter our accuracy. But we will standardize it using the standard scaler in order to reduce the effect of the outliers. Now I am performing here the feature scaling, and I perform the feature scaling using the standard scaler and make our data frame which we have more standard. So after performing the feature scaling, we can perform our clustering. Clustering I had performed is by the k-means and the agglomerative hierarchical clustering, and we have our data set unlabeled. So to make our data set labeled, I had performed clustering and make the data set labeled using the ratings from 1 to 5 according to the features which we get. And here I had used algo method for getting the exact or the appropriate or optimal value for k-means, using which we perform k-means clustering. And here we can see from this graph that the optimal value can be between 4 to 6, and I had taken 5 k value and I'm performing k-means here. After performing the clustering, I had joined the cluster column into the data frame to have an overview of our whole data frame which we are having, and we can see cluster here having the values. Now let's move forward, and we can see here that we have unique values of clusters that range from 1 to 5. And now understand the interpretation of the clusters which we formed. And here we can see that the amount of the data or the representation of the data points in each cluster. Here we can see cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. Here we can also see that the maximum number of data values that are clustered is under the cluster number 3, and the second one is cluster number 1, and the minimum number of data is under the cluster number 2. So the interpretation of the cluster is that the cluster 1 means rating 1, and similarly cluster 5 and cluster 4, cluster 3, cluster 2 are rating 5, 4, 3, 2. Now let's see the value of the number of the data points that come under each cluster. The highest number of the data points that come is under cluster number 3. Now let's visualize our clusters. In order to visualize, I had reduced our dimension because visualizing the data frame having dimension more than the 3D is not feasible for us. So I am reducing the dimension using the PCA, and I reduced it to 2. And here we can see the clusters that is formed using the clustering. There are 5 clusters, 1, 2, 5, and it looks very nice. Now I'm performing agglomerative hierarchical clustering, and after performing it, I prepared a dendrogram, and we can see here the data points that comes under the clusters. Now we have completed the clustering, and we have now labeled data that is prepared by clusters, and we can perform the classification. Here we can see that we have clusters in our data frame. Now we will train, test, and split our data into the training and testing data. Here I divided the data into the testing and training data, and we have the test size is 0.25, that is 25%, and the training size is 75%. Now I am performing the model training, and I used 5 classifiers. One is logistic regression, and the second one is support vector, and the third one is KNN, and the fourth one is Gaussian naive Bayes, and the fifth one is decision tree classifier. Now after performing all the classifiers, we can see the highest accuracy is given by the logistic regression, that is 99.04%, and the minimum accuracy is given by the Gaussian naive Bayes, that is 91.42%, and I had visualized it using the graph. At the time and while performing this project, I can get the maximum accuracy is 99.4%, and we can improve more our accuracy using the hyperparameter tuning using the grid search CV. Here I had taken parameters that are taken in the logistic regression and performed the grid search CV. After performing the grid search CV, we can get the best model, best parameter, and the best score. Here we got the best model is logistic regression for our dataset and having some parameters, and the best score given by the grid search CV is this one. Now we have put the parameters that are suitable after looking this, the output which we get after grid search CV, and the best accuracy came is 99.04%, which is nearly equal which we got above during the model training starting. And after applying the hyperparameter tuning, the maximum accuracy which I could get is 99.56%, which is fairly nice and excellent. And the error, mean square error, I had got during this project is 0.25, which is nice, very much less and good for our project. Now we will perform the performance matrices and see our performance of our dataset models trainings. Here I can see that I had prepared a classification report, and the F1 score for the classification report is nearly 1, which is excellent. And I had also prepared a confusion matrix, and the confusing matrix here I had plotted it using the heat map. After the completion of the performance matrix, I had also deployed it on a website. And here we can see that we can put the rating of the respective features and predict the rating for the location. And thank